is we're going to be talking about two major technologies that work typically in, well, thank you for turning that on, in tandem with Postgres, and that is Patroni and Citus. Now, offhand, does anybody know why this capability even exists? Patroni managing a Citus cluster? Anybody want to make a guess as to why? Well, it's real-world reasons. It's not technical. The guy got hired by Citus. He's an employee of Microsoft, and he's the one that pioneered Patroni, and they said, well, add Citus to it. And they said, okay. So he did it. Now, Patroni is actually based on another project, which I cannot remember the name. Patroni became a project around 2016, 2017. So it was based on a pre-existing project. And as with all things Postgres and Linux related, when you do a good job on a project, even if it goes dead, somebody does have the ability to carry on, to build on. And this is what happened with Patroni. So what I'm going to try to do is we're going to go through different stages on how to develop it. I'm going to take the position first by telling you the description of a functioning working cluster. And I'm using Incus. I have containers set on my environment. I'll turn them on. You can see them. They all work. And then at the stage when we talk about installing and configuring, I'll tear apart the configure and we'll just rebuild it a little bit one at a time. Okay, so there's my name, there's my email. And these are the phases. So part one, talk about the environment. Part two, talking about building it. The different packages, the different technologies that are involved. Remember, Linux, Unix, one technology built on another technology that built on another technology. They're all highly coordinated. There is no single stack. There is no finished product. It's pieces that have been designed from the get-go to interact with other pieces. The third part is we'll talk a little bit about Citus and about how it breaks down and talks about things. Now, there are basically, I'm going to use this screen. I actually made two of them, one with a light and the dark. Now, there are basically 4 separate technologies at play here. Each one is capable of a 4-hour talk. The first one, of course, is Postgres. Now, Postgres is, if you see, forget about the one at the upper right. Look at the others. That is our cluster. Each one has an instance of Postgres. The second piece of technology is Patroni. Each of those nodes holding Postgres has an instance of Patroni. A third technology is etcd. Now, I like using the expression that it is a discovery service. Now, typically, this is where architectures start diverging and they start changing. That is that little host up at the top right. In my environment, I said I am not going to create multiple instances of etcd. It is a pain to configure and start, so I'm just going to use one. And in the real world, where I have seen corporations and productions environments, there was this one client that did something very smart. They had etcd broken apart, but the proper way to do it is to have a cluster of etcd for high availability, and it was managed by another team, and they used a virtual IP. I thought that was very smart. Now, the traditional way, the way that we also at Patroni traditionally describe it, is we put the etcd on each server. But in this case, in this example, no, I just put it off to the other side. All right, so when you have this system, let's talk a little bit about how it works. Now, before I do, since it's such a nice, small, intimate crowd, on a scale of 1 to 5, like I asked yesterday, what's everybody's knowledge of Patroni? Where is it at? Is it 1, like really beginning, and 5 is a super expert? 2? 2? Yeah. Okay. Okay. All right, so then let's talk from the point of view of basics. Now, Postgres is controlled by Patroni. When properly configured, Patroni turns on, and it turns on Postgres. Each instance of Patroni in our configuration supervises one instance of Postgres. Now, it just so happens to be, if you wanted to, you could really be weird and put those instances of Patroni on another server because it's all configuration. You just point it to the right IP address. But in this case, tradition is Postgres, Patroni. So Patroni needs to inform the other instances of Patroni of its current state. If it disappeared, it must inform the others that it disappeared. If it's promoted, it must do so. If it fails, it must do so. If there's a new server that comes on, it must come in and join. And the communication medium is etcd. It's like we have a person in between here. There's Mr. AV person. You notice how he smiles. And we have a person here who walks back and forth and shares information. That's what etc does. Basically, it is a repository of information. It is a distributed data store of information. And you could actually make it a distributed database. Not very high performing, but it would work. Okay, so we carry on using two views, pgstat replication, pgget replication slots. Now this, again, I'm taking from the position of let's look at a working cluster. This is what it looks like. So you'll notice we have a coordinator, and we have 3 workers. But if we go back to the previous screen, you notice that they're paired. All right? Now, Citus, when they first started their project, they had an ability of creating redundancies, the ability to duplicate or triple or whatever a table, and you could point to whatever servers. They found out that that model was too complex when it came to scaling. So they decided we're going to use a traditional primary replica configuration. So for every worker, there is a standby. For every coordinator, there is a standby. Patroni integrated that concept and uses it. This is how it's going to work. So every standby, it is read capable, but Patroni only administers and cares about the primaries. There are instances of Patroni on the standbys, but they are passive. Okay, so again, we have our looks. You can see the slots, and you can see, look at the synchronous state at the column, the last column. It's all synchronous. That is an arbitrary decision. All primaries have synchronous replications with their standbys. There is no async. There is no mode in this version of Patroni to change it. Could you change it? Yeah, you could hack it. Should you try? I don't know. Okay, so this is what it looks like when it works well. Has everybody had the experience of working with the Patroni CTL command line? Okay, so you haven't had that chance. When you work with Patroni, there's the service Patroni, and then there's the command line utility, Patroni CTL. It has an entire list of commands. The first thing you have to do whenever you use Patroni CTL is to point to the configuration file that you're using. This will synchronize and tell you the state. So look at the first column, group, 0, 1, 2, 3. 0, by default, is hard-coded. That's your coordinator. 0 will always be your coordinator when you assign definitions and identity. From then on, all integer values are the identity of the worker node. So when you see 1 and 1, you can see on the next column over, under role, leader sync standby. Now there is a mode previous to this implementation of Patroni where you could create what was called a standby data center. And it uses that functionality. It would, basically, you would set up a server remote. It would be a replica. And it would be known as a standby server. So it would receive input as if it was a replica. And by cascading replication in that remote data center, you'd have another network ready to be used. To promote it, you either had to promote it explicitly using Patroni CTL, or you use the Patroni API, which commonly you could use curl and send off the signals. So we've got leader, sync standby, leader, sync standby, et cetera, et cetera. You can see the states. That tells me everything's working properly. If you don't see these commands, it's either changing state or there's something wrong. Now, in the manner that I created this instance, this cluster, the next column, TL, does everybody know what TL means? All right. Have you ever heard of the expression timeline? When you have an instance of Postgres and you create it, let's see, I'll bring up the file manager over here. And I'll show you a typical cluster. Let's go to 16. Let's go to the wall. Okay. Looking from the left, you see all the zeros? You see the number 1? That's a timeline. Every time you have a cluster and you perform the failover, the node that is promoted, that switches and increments by 1. That becomes 2, or 3, or 4, or 5, every time you fail over. When I used to inspect clusters, this is how I knew how many times they had failed over the system. Everything else to the right, of course, is the hexadecimal address system, which allows us to identify individual walls as they increment. Yes, using either a promotion command or, well, there's a number of techniques of promoting it. But basically, that node that is a replica is now a read-write, and then it is up to you to turn the other nodes into replicas for that one, which Patroni does automatically. So in this way I created the system, I started with a timeline of 1, but Patroni, to do all the synchronization, it went to a second timeline. Now, that's not to say that the system, the method that you choose will be exactly the same as mine. This is the particular way it turned out for me. Okay, now, when you create Patroni and you do the configuration file, it is going to create its own configuration file. This is a copy of PostgreSQL.conf. It has been taken over by Patroni and overridden. If you look at the very top of the file, see the include, PostgreSQL.base.conf? That was the original configuration file. It renamed the file to base, and it renamed itself to PostgreSQL.conf, and within the Patroni configuration file, you assign runtime parameters. And those are the results. Now, some of these you need, some of them you don't. In my particular case, for example, archive command, archive mode, archive timeout, you really don't need that. I just put it in because it was the state of what I was doing. But what will be required, Citus must be installed. And that is near the bottom. Shared preload libraries equals Citus. The other Citus runtime parameters, they are generated automatically after the extension has been added and the server has been turned on. They will become available at that point. Now, this is an Ubuntu distribution. So the configuration files are not located in the data cluster path. They are located as per the Debian protocol in the etc directory, which is very confusing for people who grew up with CentOS and Red Hat. It is a method that is consistent with all services on Debian distributions. It is meant to be more secure. It is also more confusing. Okay, so let's start now. We have demonstrated the very, very basics. As I said, if we had the time, we could play with Patroni CTL and you'd see all the wonderful options and do failovers and everything. The objective of this presentation is to give you enough information to build the environment, and then you play with it. Now, the title is exactly what I'm talking about. There are so many inconsistencies across the Linux world about versions. Let me see if I can do it without using up the entire presentation. Let's start with the top left. In creating this environment, we at Patroni have our own distribution. This is not that different from the community version. What it is, it's curated. We've added extensions by default that are available automatically. As part of the distributions, we also included etcd, and Patroni was also installed. Now, take a look at the version of Linux, Ubuntu 24.04. First caveat, using the standard packages on 22, on the previous version, the one that's still alive, but will be deprecated in about a year or so, it doesn't have the sufficient version of Patroni to make this work. We need at least version 3 dot. At least that. That is where the Citus was incorporated. The previous versions, if you install, you have to find out what version of Patroni you're using. If you've got a 2 series, this isn't going to work. You need the 3 series. The second thing is we're using 16. Now, etcd, look at the version that I've got installed, 3.5.14. On Ubuntu, you have version 3.4. Well, guess what? The configuration I'm about to show you doesn't work on 3.4. They rewrote etcd. It changes radical behavior. So we happen to have on our Percona distribution the 3.5 version. And the only way you get 3.5 is either through us or you download the source code and you compile it yourself. Default Linux distribution, on Ubuntu at least, is 3.4, which means the configuration file will be different from what I'm about to show you. Now, the Patroni version, you'll notice to the right I said community version 3.22 is available, which is not as advanced as 3.3 that I'm using. It doesn't matter. It's a 3 series. But 4, if you go to the Patroni documentation, it's 4. And 4 has radically different behavior. It includes runtime parameters and instructions that will not work on 3. Welcome to version hell. To get around it, you'll notice here, if you're going to follow the example that I'm presenting here, I would suggest that you go to the release 3.3. That will show you the correct information. Now, the reason that it's different is because the 4 adds a new runtime parameter for Citus, and it does things automatically that you have to do explicitly in 3. For example, we're going to use a database. We're going to call it pgbench. Well, if pgbench is not there on 4, it will create it and install the extension automatically. On 3, no. You have to go in and create the database yourself. It will fail otherwise. I would like you to take the time, if you want to pursue this in your own time, take a picture of the references below. Specifically, the last line, the GitHub. That is the path I presented on my yesterday's talk, and I'll present here now. This is going to show you a few things. It's the slides, the references, and also there is a package, Debian package for Citus. It's pre-created. It will work on version 16 Postgres. Okay. Oh yes, one other thing. The Citus version 12.1, it changes version. If you go to 11, there are certain things you can't do. If you go more advanced, there are certain things they write that you can do, but that you can't in 12. So as I said, there is this incredible inconsistency. You should have seen the strip I took off an Ubuntu canonical person when they came to our little booth. I gave them shit because of this inconsistency on Ubuntu. So hopefully, I wasn't too hard on him. He'll go back to his team and he'll say, look, we need to make our distribution a little more consistent. Okay, so these are the steps. You're going to get your packages. It's either going to be the Debian, it's going to be GitHub, it's going to be through pip, whatever. You'll get your versions. Afterwards, you have a cluster. You're going to initialize. Again, now, if this is the method used in this presentation, when Patroni has a properly configured file and points to a proper Postgres version, even if you don't have a cluster, it'll create it and deal with it itself. On Ubuntu Debian distributions, as you may realize, that distribution, when you install Postgres, it automatically creates a cluster and starts it. That you have to deal with. On CentOS, Red Hat, no. It just installs the binary. So that's another thing you have to keep in mind. You set up etcd. As I said, in this particular implementation, I'm only going to do it once, and all the Patroni services are going to point to that, which makes it a lot easier. We need to create a database. We need to update systemd so Postgres doesn't turn on itself. You set up Patroni. Patroni turns on Postgres. Many times people have forgotten or didn't realize it, and Patroni refuses to start. And if you use the example configuration files, there is no logging. You can't figure out why because you turned it on the systemd. It just says, hey, there was a mistake. And you'll never figure out why, that's because you had another server running the system. It doesn't have the ability to kill the Postgres and take over it. We set up Patroni. We put in the configuration files. We start. Now, there is a way I'm going to show you. This is not documented. This is an unofficial way of a tip on how to deal with Patroni when you start it up. You won't see this online. You won't see any documentation about this. This is new. Then, finally, we're going to set up pgbench, and we're going to go through Citus. And Citus, again, as I said, it is a world unto itself, but when everything's configured, it's automatic. Okay, so this is what it looks like, pghba.conf, and in this case, I've used Postgres and I assigned a password. If you go to the Citus documentation, they'll say, use trust, use trust, use trust. No, use a password, be realistic. They don't tell you these things. They don't say use pgpass. So keep in mind, remember, this is all libpq conformant. It will read properly. Oh yes, one other thing. Has anybody ever dealt with IP version 6 much? There are entities out there who do. So they're listed there, IP version 6, to be consistent. A lot of people just use IP version 4. If you don't define the paths for IP version 6, and it does use it, the default is only localhost is accepted. Now, in my environment, it does name resolution using version 6. So I had to configure it. Otherwise, it won't work because it won't recognize PG1 or PG2 as a host identity. Okay, this is the etcd file. And what I've done is I've left in the variables. So what's going to happen in this case, it's a single instance of etcd, and this is copy-paste. I just replaced the variables with the real identity. Host is a physical name. You give it any name you want. It's its own identity for that instance of etcd. Initial cluster token, in that case, we normally say Patroni, any string. It is going to be consistent among your clusters of etcd. Again, we're using only one instance, so you can name it anything you want. Cluster, again, the same thing. We're going to call it PG cluster. And PG cluster, when we did the list, it always identified the cluster using that string. I'm just going to go back a few slides. Right there. Look at the top left. See where it says Citus cluster? Right after that, colon, PG cluster? That's where the name comes from. You assign that in Postgres. You put that in etcd. And data directory, host IP address. Again, this is for the 3.5 version. It will be different for the other versions that are currently still maintained. The good thing about using this is you're going to be ready when the distributions switch over to 3.5. Okay, now, everything's configured, everything's ready to go. We are on the primary and every worker node going to create a database, and we're going to call it pgbench. Now, we've configured ahead of time only the primaries. The standbys, they're there, they've been identified, but they're empty. There's nothing there. The servers are not on, even the data clusters have been removed. We need to turn off Postgres. If this was Red Hat, we wouldn't have to worry about it. But because the data cluster has been initialized using Ubuntu, we need to stop it, we need to disable it, and we need, on the standbys, to remove the data cluster. This is a full copy of Patroni. I've got a few more slides that does close-ups. Now this is a simplified version. Each one has its own things to do. I'll go through it when we go through the close-ups. Now, the secret, if you look on the left, on the top, do you see the word, the string Citus? That's the only thing you have to really understand to make a Citus-enabled cluster. That line, that's it. Now you see the bootstrap below that? You see in the comment, synchronous mode quorum, it's commented out. That's Patroni version 4. If you were to use that version, that would have to be uncommented. Okay, so here's the close-up. And this is where I don't like the Patroni documentation, because when you look at the terms, they don't indent them enough. You can't figure out where they're supposed to be. And as you know, with YAMLs, your spaces are very important. Otherwise, it doesn't work. So in this example, I added log. Please put in the log so you can at least see what's going on. REST API, listen, this is the local host, which allows you to use the API as you wish at some future date. And etcd, I'm using 3.5. It has to be defined etcd 3. If you use an older version of etcd, that has to be etcd. As I said, this is version hell. It is going to be confusing. Citus, as I said at the outset, there's only 2 parameters, group and database. The database we created ahead of time. The group, 0 is for the coordinators. All non-zeros are worker pairs. And by the way, you can have as many workers as you want. If you had 3 servers for worker number 1, yes, then you'll have 1 primary and 2 replicas. It's that easy. Okay, the rest, you'll see the DCS. There's that commented line, synchronous quorum. And again, some of this stuff is fairly standard. Very, very simple, very straightforward. Now the lines, PGHBA, users, those things normally don't come into play unless you use the Patroni CTL command to say initialize a new cluster. Otherwise, if you have an existing cluster, it'll just use the existing cluster. It won't rewrite it. Okay. Here's the confusing part. This is a Debian distribution, so you have to point it correctly. And in this case, I did something very simple. I just used superuser Postgres, and the password is Postgres. Nothing complicated. When you create your environment, dumb it down, because don't worry, you'll get to make it sophisticated. It'll be very confusing. The bottom tags, you can tell, you can inform which cluster can be used for failover or not failover. When it says false, it means that all of the replicas that are attached to the primary, they're all available for failovers. Now, by default, we've got 1 replica for each, so normally you wouldn't do that. But if you do get multiple copies, say, of coordinators, you could say, okay, I just don't want to use it for a failover situation. And I have configured clients where we actually had servers that were connected that we didn't want to fail over. We wanted them to be part of the cluster that could be administered, but would never, never be promoted as the primary. Load balance, clone from, no sync. Again, the documentation will show you all this nicely. And there's also another ability. You can define your own tags. You could write anything you want, any name, then colon, and put a value to it. And this was useful, again, for a client, because I needed to identify ones as standalones, as replicas, as one for belonging to a particular client that they were servicing. Another one was strictly for logical replication. It was easy when we used the list command, because then we saw all the assignments. This is the technique. You have everything installed. The version is correct. You've created your configuration file. You're going to test 1 server. You're going to test the primary coordinator. You're going to use these 3 commands. First, you're going to come on the command line and you are going to sudo as Postgres, non-super user. If you use a super user, the files, the permissions will be super user. And that will conflict with Postgres. And Postgres says, no, I can't read root. It'll do all those wonderful things. So common practice is to run Patroni service as the user Postgres. But when you get comfortable, you could always create another user account, and that user account runs Patroni, and you isolate it, and it's more secure. Patroni validate config. All that does is it checks your syntax. It will also see if there's another running version of Postgres. It will also see if the files in the data cluster are the correct permission. The test is where you run the command line Patroni and you point the configuration file. What happens here is it's going to turn on the Patroni server and it's going to turn on Postgres. All the messaging, it comes out on standard output. That's the secret. That's the technique to validate your entire process. If there's a problem and you use this technique, it will tell you why. It will tell you where the permission is wrong, where the service is incorrect, if you're missing a configuration file. If you use the last command, the systemd command, it'll just tell you it failed. That's it. And you'll have to guess. So use this approach. Validate, test, start. Now, when you do the test, you're actually running Patroni. Typically, what I've done is I just run one node, and when I'm satisfied, it'll do what it's due. It reaches stability, and then I do Control-C, and it shuts itself down nicely. Then you can turn on systemd, the systemctl command, because now you know it's going to work. You have a choice. You could do this just on one. You can do them on all of them. That's up to you. This is what it looks like when it runs correctly. Now, at the end, you'll notice the second line for Postgres, user live PostgreSQL 16 bin. The configuration file, that's Patroni's pointing it out. Now, all this, there's a command line that's going to go on and on and on, and it shows the DCS runtime parameters. Those runtime parameters you cannot change. They are defined in the DCS, and it's there that you edit it, because these are runtime parameters that Patroni has been designed to run consistently across primary, replica. It's consistency for replication purposes. So it can't be changing your configuration files in PostgreSQL.conf. It's the DCS, and that is done on the fly. Now, as you can see here on the bottom, you see those instances of pgbench? Well, that's Citus. It worked. The Citus extension has been created. The database is empty, but the extension is active. Okay. Here is the dynamic configuration setting. Now, there is a command line, Patroni CTL, point to the configuration file, and then there's this line, edit-config. That's the command to get to this. And then your default editor, whether it's Vim or Pico or Nano, will suddenly present to you a text file, and you can edit. And then you change it, and these commands will be propagated across the entire cluster. These are common commands. Here's our startup order. So we've been going through the steps. We've validated it. Okay. Start with the primary. Then you go to the first worker. And in the workers, they're odd-numbered, and you see the standbys are even. That was just my naming scheme. That's all it was. So 1, 3, and 5 are primaries for each worker group, each worker pair. And the reason why it started discretely is because I've made the decision I want to control which node is going to be the primary and which one is going to be replica. You could turn everything all on at the same time, but then it's a race. Patroni will randomly decide which one's the primary and which one's the replica. You don't get a say, at least until you go to 4, and that's another story. Okay, at this point, questions? All right, here we go. We have a working Patroni. The key was those simple parameters. The exercise was twofold. Get the configuration, get your binary packages. Make sure the versions are functional and correct. etct is critical because the way you configure depends on the version. The features, Patroni has to have at least version 3. If you go to 4, you add new features that you have to take into account. Okay, so Citus. Does everybody have a familiarity what Citus is? What it does, basically? So just to rehash, Citus is a now popular way to scale Postgres horizontally across nodes. And it has the ability to put tables across the nodes in an automatic fashion. It's very, very cool. It uses logical replication, and you'll never see it because they rewrote it so that you can't detect it with the normal metrics. This is what it looks like. We have a coordinator node, and we have workers. You can have as many workers as you want. And when the version of Citus is advanced enough, I think 12 does it now, you can turn a worker into a coordinator. There's all sorts of cool things. This is the simplest configuration to understand. A coordinator node and a worker node. These worker nodes are where you distribute your tables. Now, you're not going to have just one type of tables. There's actually 4 different types, which is why we're covering them now. Ordinary table, a heap table. Create table, there it is. Citus can take care of it. That table typically is standalone and will be unique on the node that you created it on. It is not touched by any of the other nodes that Citus, because you've created a standalone table. The second type, what we all understand is important. A super large table that is distributed across the workers that you've defined. Now, in this case, we have predefined 3 worker pairs. You could start with 1, and then you can add workers, and then you shuffle the table so that it's balanced correctly. Again, this is something that you could go quite at length when you talk about Citus. We can't cover it because we don't have the bandwidth. Here's another type. A distributed table, co-located. This has to do with the fact that if you have a distributed table and you use foreign keys, well, you need to co-locate that table. Table T1 is the big one, and if you're going to query and use foreign key constraints, table T2, it's going to be designed such those records will be common on that table. Now, by default, when you create it, there are 32 shards. You can change the number of shards, and you can shuffle them around, you can increase them, you can reduce them, but the default at the starting point is 32 when you create a distributed table. Here's the last type, a reference table. You have a copy. This small table has all the common key values that the distributed table sees. What you're doing is you're copying table T2 over and over and over again across each worker node. The idea is for performance. Instead of going out and searching for the record, which is on another node, it's on the same node, irrespective of what the other table is. So if you distribute the table with table T1, it's huge. You have a smaller set of tables, the reference table, and it's copied over and over and over again. This is an example, a simple example. Now, I made a mistake on the schema, so I'll try to define it. You see on the left there, it says T2, T1. It should be the other way around. Look at the commands on the right side. You're going to create a table. You're going to create 2 tables. Table T1, table T2. T1 is the reference table, which means it is copied over and over again. And you'll see that correctly it should be all labeled T1. And those records are copies. They're always going to be repeated the same way, the same order. Look at table T2. Again, I apologize for the first square. But look at the shards. Technically speaking, those shards are unique. They will never be the same on any worker. That's the distributed table. And when you have referential integrity, they'll always refer to that reference table, which it will see instantly. If you don't have a reference table, it won't break. It'll just go wherever that record is, and it'll take more time. Yeah, copy paste. You're not going to get a prize for that, you know that, eh? Okay, so here we are at the last stage. Has everybody had the chance of working with pgmatch? Okay, 4 tables, 3 of the 4 have primary keys. You need a primary key for logical replication. The 4th one has no key. If for those who were present yesterday, remember I talked about alter table replica identity? You are informing, you are putting the necessary information into the write-ahead log. You don't have a primary key. You have to do it here as well. If you forget, don't worry. Citus will come back and spit at you. It'll say that it's not going to work. So what we've done here is we are saying create a distributed table, create a reference table, add the referential integrity, alter the tables. Now, anything previous to the version that I used in this demonstration, just that simple command of adding referential integrity, it will fail. It's really weird. Again, it's because of the version. All of these projects are advancing so fast that they have features that are incomplete. If you use, say, version 11, you couldn't add alter the table referencing. What you'd have to do is you'd have to create a index and then refer the index to the column. It's a stupid hack, but it works. So try to keep up with 12 or more recent. This is what it looks like. This is how our system is. Now, notice at the bottom, accounts. I did a scale of 300. By rights, table history should be the one that's distributed because over time, that's going to be the bigger table. But for our purposes, it was more fun to redistribute 3 million records across the 3 worker pairs. So I used that, and the reference tables were the others. By the way, performance still sucks. Okay, so this is the last thing. This is a query. Look at the top. Select all from Citus tables. You'll notice the type and the size. You can execute that command on any node, coordinator or worker, and it'll show you the results. Now there's a complete API with Citus. Again, take the time, explore it. Citus portal is really good. They are so good at documentation. Here's your summary. Get, install, configure, create, pgbench, Patroni, pgbench, configure, data populate. And now I've got 5 minutes, which should give me enough time to actually run the demo. And I'll show you what it does. So again, there's a little reminder about the GitHub. I don't expect you to know everything just by looking here and sitting down. If you've got the bandwidth, go to the GitHub, get the packages, play with it. Then you'll have a wonderful excuse to tell your boss, I deserve a raise. It works. Okay, let's see now. Where am I? All right, now, I'm using Incus. I have my containers. Right now, they're all started. I'm going to rebuild it. And below what you have are all the scripts. So the first thing is I'm going to go to 0.1 and tear apart everything and let it run. So it's dropping the containers, and it's using template Patroni Citus, which is a common template. All the common configurations for Postgres is already built in, so it's just copy it. So you try to be as consistent as possible between all the instances of Postgres. Okay, it's done. Set up etcd, which is really simple. Since I have one instance, all I have to do is shove it in. Now, by default, when you install etcd, it is running. It is configured. All you have to do is replace the configuration file. Now, what I've done here is I turned on etcd so it would start up automatically. So I just enabled the service. And you'll see the last command is an etcd list member. If there was a cluster of etcd instances, it would list all of them. Now, as with Patroni, there is a leader. There is one that's in charge. All this does is it creates pgbench. We have to create it using this version of Patroni. We have to put pgbench on every node. Now, right now, we're working only with the primaries. We're changing systemd. We don't want Postgres to start up on its own. We want Patroni to run the show. I put a sleep in there on purpose, just so that it wouldn't do anything stupid. Okay, next. Now we set up Patroni. And Patroni at this point is you put the configuration file across all the nodes. The only thing here is there's about 3 or 4 lines in each file where it's different. Those lines pertain to the IP addresses of your local host. That's it. That's the only thing that changes. Otherwise, they are consistent across all nodes. Now in here, I've got 2 choices. One is to start it up. It's going to take about a minute. So the second script I have just monitors its state. It just does a little looping monitoring. So we're going to do A. And what this does is it's going to go in and it's going to start it up. I already know that it's going to work. So I'm not doing the manual test with Patroni. I'm just turning on the system. Okay, so it's now enabled. Now it's starting. And now we loop. And look at the state. Look at the column. State, running, creating replica, running, creating replica. Now these are empty data clusters on a single machine. So you can imagine in a production machine, this is going to take time. Now we're using the default configuration, PG-based backup. A sophisticated production quality Patroni cluster will use a solution like PG Backrest, which can run much faster because it's multi-threaded. And we see that it's stable. Notice the timeline. They're all 2. They're consistent. And one more little thing, and that is this one here. Oops, 0. Oops. There we go. And that's a little script that gives me the state. It just does a few queries and gives me the controls of what's going on here. All right. And you can see at the very top the nodes, see the IP addresses, and see the groupings. So this queried the primaries. Now remember, the standbys are still read capable, so you can do all sorts of things. You could still use it. And if you had something like a load balancer in front, you could interact and use the workers as well. And that is it. Questions? All right, I hope you didn't fall asleep.